this very complicated topic in a very simple way. This everyone struggles for oncology boards, soft tissue sarcoma. So let us classify the soft tissue sarcoma into what the normal soft tissue components are. So if you have soft tissue, the first thing is you'll have membranes which seal off the soft tissue. Then you have epithelial lining around and inside the membranes. You have stromal tissue. In the stroma, you have blood vessels, you have muscle, you have fat, and you have fibrous tissue. So if you classify it like this very easily, you can remember the entire soft tissue components and then make a cancer of each of these. And remember that most of these cancers have targeted the platelet derived growth factor and the platelet derived growth factor receptor. So remember this target. Okay, target. Okay, and then you start labeling each. So T. So T is like the membrane here. So T is tenosynovial giant cell tumor. T. Tenosynovial giant cell tumor. And you have over here what you have the giant cell synovium, tenosynovial giant cell tumor of the membrane is is the first one. Then you can also say synovial sarcoma, which is the second one. Okay, and then you can say for the fibrous tissue, you can have a solitary fibrous tumor, or you can have dermatofibrosarcoma protuberans, and you can have desmoid tumor. These are all fibrous. If you come to the fat component, you will come to liposarcoma. We'll have a well or a dedifferentiated liposarcoma. And if you come to the blood vessels, you can have an angiosarcoma. If you come to the muscle, it is rhabdomyosarcoma, and if it is in the nerves, the nerve sheet, you have MPNST, malignant peripheral nerve sheath tumor. Okay, so that's how you will conceptualize it. Once you've conceptualized and organize it very easily, you know that all of these have usually the platelet derived growth factor, or there is some tyrosine kinase receptor, which is the receptor tyrosine kinase, where you have growth factors and then you have the downstream pathways. So anywhere in this entire cascade, you have to target it. So for targeted therapies, usually it will have a receptor like a tyrosine kinase inhibitor, and then you can also have like a VEGF inhibitor like bevacizumab, or you can use immunotherapy, or you can use even chemotherapy, such as uh, docetaxel, itamicin, etoposide, so IE, IA, so you have different regimens for managing soft tissue sarcoma like VAC or like anthracycline gemdosi. Okay, so uh, like you have to understand the concept and then choose the treatment. If it is a KIT platelet derived growth factor, if it is a PCOMA, so let's take it one by one. If it is a tenosynovial giant cell tumor, the molecular abnormality noticed in the target fashion is CSF1 fusion and overexpression of CSF1. So there is increased macrophage recruitment and joint destruction. CD28 and CSF1 will be overexpressed. This is chemo-resistant and not radiosensitive, but there is some CSF1 inhibitors such as pexidartinib. Okay, so remember that tinib start with this pexidartinib. For the solitary fibrous tumor, you know what's happening here is you have a STAT6 fusion, NAB2 STAT6 fusion, and your temozolomide and bevacizumab is used. In the alveolar soft part sarcoma, alveolar soft part sarcoma, TFE3 fusion, angiogenesis, upregulation, nuclear positivity, antisol, VEGF-TKI, angiosarcoma, facing MYC amplification, and pazopanib, paclitaxel. RMS is a separate topic, MPNST is a separate topic, and GIST is a separate topic, PCOMA, CD117, epithelioid sarcoma, SMARC, CB, EZH2, dexamethasone, pazopanib for endometrial sarcoma. Despite tumor is activation of CTNNB or WT pathway. So WNT binds the ligand, and you have the beta catenin. You have the beta catenin degradation complex. And when this mutation in this beta catenin degradation complex, you have APC, adenomatous polypeptide, and you have alpha catenin here. So when this is abnormal, you have overexpression of this, and you have desmoid tumors. That's why you see desmoid tumors in APC. And then you can have dermatofibrosarcoma protuberans, which is very bad, and you can try to use imatinib there. In liposarcoma, amplification of MDM2 block, CDK4 to G1S, MDM2, CDK4 are used. So that's how we'll classify it and approach each one. Let's see the principles of management. Now, if it is tenosynovial giant cell tumor on the membrane, CS gives an objective response of 39%. Temozolomide and Bev give an objective response of 40% at solitary fibers. Alveolar soft part tumor, alveolar soft part tumor with transfer TFE3, antisol, and VEGF-TKI give a good response. Angiosarcoma in this dermatofibromatosis sarcomas, you have a coli and platelet-derived growth factor. RMS FOXO fusion, GIST, TSA, SMARC. All these are actually kind of resistant to treatment, but in desmoid tumor, there is something called nirogacestat. It's the gamma secretase inhibitor. Dazimetostat for epithelioid sarcoma. mTOR inhibitors for tuberous sclerosis, PCOMA. Well, we've just gotta keep like recapping it like that and remembering it. Tenogenevial cell tumor, you have the call 6 CSF1 fusion. So basically, these are a lot of fusions with anything connected to the platelet-derived growth factor. And when you come to radiation, ones with this myxoid lipo is very radiosensitive. Synovial sarcoma has a good response to radiation. Pleomorphic undifferentiated has a good response. Leiomyosarcoma and MPNST, all these membranes seem to respond better to radiation than the blood vessels, and then the fibrous ones are the most least responsive. So it's just general, but when it comes to other targeted agents, you should try to put NTRK inhibitors such as larotrectinib, entrectinib, NTRK fusion positive tumors, especially like undifferentiated sarcoma. As NTRK inhibitors can be response but fail. There's three NTRK receptors, TRK A, B, and C. 1, 2, and 3 code for these TRK and neurotropin. And then when you have NTRK fusions, you use NTRK inhibitors and larotrectinib, entrectinib. These are the TRK inhibitors. Pazopanib is another important agent because it's a TKI, which is almost VEGF and non-VEGF platelet-derived growth factor kind of TKI. So think of it like that. Trabectedin is an alkylating agent which binds to the minor groove of DNA, unlike topoisomerase inhibitors, and it traps the double-strand NER repair machinery. Very effective in liposarcoma, so the soft tissue sarcomas. It's just like which part lipo, leo, undifferentiated, sino, rhabdo, mixo, angio, epithelioid, clear, fibro, dermatofibromatosis, desmoid, chondro. So just know that and then briefly know about the staging and the grading. Here, there's a three-tier grading system. So if you have to remember staging, T1 is less than 5, T2 is 5 to 10, T3 is more than 10, 10 equal to 15, more than 15 is T4. Look at the differentiation score 1, 2, 3. 1 is it resembles a normal mesenchymal tissue. 2, see the type, and then embryonal undifferentiated. Look at the mitosis score 1, 2, 3 is 1 is less than 10, 2 is 10 to 20, 3 is greater than 20. Look at the necrosis at 0, 1, 2. Less than 50% necrosis is 1, 2 is greater than 50, and 0. So then you finally put a grade. In the grade, you will consider the differentiation score of 1, 2, 3, mitotic score of 1, 2, 3, and necrosis score of 0, 1, 2. So if it is like a high total differentiation mitotic and necrosis score, it would be grade 1. If it is a high total differentiation mitosis and necrosis score of 6, 7, 8, it would be grade 3. And total differentiations for mitotic score, necrosis score of 4 and 5 to be grade 2. So with all of that, we use a three-tier grading system for soft tissue sarcomas. And anything that is grade 2 and grade 3 would be in stage 2, 3, and 4. Anything that's metastatic would be grade 4. Any grade 1, that is the differentiation score, mitosis score, and necrosis score, DMN. Okay, so remember that. Though a lot of these have very peculiar molecular abnormalities such as cyst and kit, these are the most treatable soft tissue sarcomas. Then the well differentiated and de-differentiated, they have giant ring chromosomes, CDK4, MDM2, synovial sarcomas, alveolar soft part myxoid, Ewing's desmoplastic alveolar abdo. So just have this overview. Well, and then like based on which kind of sarcoma you get, you're gonna have a hard time because you have to be able to like identify first which tissue is proliferating. Is it the fat? Is it the muscle? Is it like fibrous tissue? Do an NGS and do IHC. And then based on like some particular like characteristic molecular abnormalities, if we see a translocation 1722, then it could be dermatofibromatosis. For example, if you're seeing this alveolar soft part with TFE3, CSF1 with col6A pexidartinib, if it's a soft part, sarcoma, tumor, zolamide, BEV, figure out all of these and solve them one at a time. Thank you.